Hi everyone, welcome to the Art of the Possible series. I'm Nihali Niyogi. I'm a principal cloud architect at Microsoft, and today's topic is integrated NVAs in vWAN and more specifically firewall NVAs. With me, I have two amazing guests. I have Cynthia Treger, who is a global black belt at Microsoft focused on Azure networking, and I also have John, who is a Cloud Alliance architect at Checkpoint. Cynthia and John, I have truly enjoyed working with both of you on this series, so thank you for joining. And so to recap, this is part two of the session with Checkpoint. In part one, we did a deep dive on design options. Today, John will be showing us the lab and the different components that we can do validations on the Azure portal. To set the stage for this conversation, I'm going to run through two distinct scenarios. So let's talk first about secured vWAN hub. When you have secured vWAN hub and notice this little firewall icons that lights up, we have north-south flows funneling through the firewall, and we have east-west going through the firewall. Um, Notice this blue flows. This blue flow will bypass the Azure firewall, and the idea is that that inspection will happen on-prem. And then the ER to ER flow. So if it's an express route connected branch to another express route connected branch, will not flow through the firewall. You could either use global reach or routing intent. And then we have inter-hub flows. That today will also, with secured vWAN hub, will bypass the firewall, so it can go through the global reach. And one more routing consideration is that spoke to spoke, so one spoke in one region to spoke in another region, is not supported with secured vWAN hub. So potential solutions for that is routing intent. So with that, Cynthia, I'd let you comment on some of the flows here and highlight some of the important points with secured vWAN hub as well.
Nehali, and thanks for highlighting that routing intent is different from having an isolated secured hub. And what is important to note is that without routing intent, using only a firewall solution in the hub doesn't allow inter-region and doesn't allow branch-to-branch inspection. And I think that's the main things that the two main inspections that will become available with routing intent, but that are not available as long as we have only secured hubs.
Exactly. So the blue flow and the red flow, essentially. Thank you, Cynthia. So now, as Cynthia mentioned, with routing intent, so let's talk about with routing intent, what happens. So remember that those blue and the red flows that were not possible. With routing intent, everything can be funneled through the Azure firewall over here. And of course, for ER to ER transit, you do need to open a support case to enable that, enable routing intent with ER to ER transit through the firewall. And then let's talk a little bit about the routing consideration over here. If you do want to have subnet to subnet go through the firewall, and John's going to show this with integrated NVAs as well, but you could use an UDR to Azure firewall for that. And just one last flow that I want to highlight. Notice how with routing intent you could do inter-hub. Like Cynthia mentioned, inter-hub was not possible with secured vWAN. This one is inter-hub. Notice it traverses the firewall twice. And so all of these, if I highlight all the flows, this is what it looks like. Cynthia, anything else you would like to add?
Yes. Important thing to notice as well with routing intent is that we have two types of policies. We have private traffic protection and internet protection, and they can be enabled independently. So we could use the firewall solution in the hub either for internet protection, for internet access, or for private traffic protection, so VNet to VNet or VNet to branch.
Good point.
And the moment routing intent is enabled, whether for internet protection or private traffic protection, the firewall for that given type of traffic becomes the central point of attraction of any flow.
Yes, absolutely. Yeah. So like Cynthia mentioned, internet is those pink flows, and then the private would be this orange and the blue flow. Excellent. So now that sets the stage for today's discussion, which is bringing in partner NVAs, right? So from a placement perspective, any integrated partner NVAs kind of sit exactly where the Azure firewall sits. So this is the main topic of today's discussion. This is an integrated NVA or a firewall NVA. And so this is where you could have the north-south going through the Azure firewall, and you could have the east-west going through a partner NVA. In this case, we have Checkpoint. Anything else you want to add, Cynthia, over here?
Actually, I want to add one more thing.
Sure, absolutely.
So I just want to share that one of the main feature what a customer really love about the vWAN is the fact that whenever there is a new VNet that is provisioned attached to the vWAN hub, that subnet will get advertised across to the different hubs, right? So what that alleviate is the customer having to define a UDR and then doing the manual peering and define the UDRs on the routing. So with the virtual WAN, all of that is taken care of for our customer. And that's whenever I talk to vWAN customers, that's something that really resonate with customers, especially those customers with over like hundreds of VNets, right? Having to manage all the route tables on it is quite complex, and this drastically simplifies all of that. So I always want to highlight that point here, and before I go into my bits there. So.
Thank you, John, for sharing that. And Cynthia, you had a question.
Yeah, I just wanted to highlight that here in the vHub, we have both an Azure firewall and the managed checkpoint NVAs, each managing either private traffic or internet traffic. But of course, it could be the same device managing both types of traffics.
Exactly. Yeah, good point. So with that, there's one, I just want to share a piece of Azure documentation that highlights the different partners. And again, today's session is about this one, which is north, south, east, west inspection, and more specifically, checkpoint. And with that, over to you, John. Please take it away.
Okay, thank you, Nahali. Thank you for having me, guys. So I'm going to start sharing my screen, and I'm going to focus my session really around the what customers see in our in the Azure Portal, right? And also going to touch base on a little bit about the different route and what that looks like, with the with and without routing intent. So let me share my screen here. Okay. Let me know you guys are ready.
Yep.
Can you see my screen okay? Okay, yep. Great. So guys, what we left off from our first session is finishing installing our the checkpoint firewall inside the vWAN hub. So next I'm going to show you guys some of the different routing intent combination that Nahali mentioned earlier. So I'm inside the one of the vWAN hub in West US, and then under routing intent. So in the routing intent, as Nahali mentioned, you can actually split between the different security providers. So in this example, we're using the Azure firewall as the internet So all the internet traffic will get routed to the Azure firewall. And then for all the private traffic will go through the checkpoint. And of course, you can mix and match this combination, and you also mix and match, other security providers here as well. One thing that, come to mind is the security in depth, right? So in the past, customers would implement, or is it recommended to have a two-tier firewall? So like a different brand, right, or different vendor firewall for one tier, another provider for another tier. So for those customers who are still using that model, you can implement that here, and obviously, of course, you can also use the checkpoint firewall. You can have both checkpoint or both Azure firewall if you want for both the internet and private traffic. Okay. Nahali, sorry, pause here. I can't see your hands being raised. So in case you guys have any questions, please feel free to jump in. I don't see it here for some reason while I'm sharing the screen. So
Yeah, no worries. Yeah, so yeah, when you pause, I'll ask the question. So John, real quick, this is very interesting. So you're saying that you could have two different checkpoint clusters, one for internet traffic and one for private traffic.
yes, you can do that as well. Yes.
I
So
see.
yeah, and of course, like it really depends on the customer's traffic profile. So if the customer kind of light on the internet tier, so they can actually install a smaller scale unit of the checkpoints for internet. And if they're heavy on the east-west traffic, and most customers, are heavy on the east-west, so they can deploy a bigger scale unit. The other benefit of that, this separate the two tiers is it makes it also easier for maintenance as well. So if you need to do maintenance on the internet firewall, you're not going to be impacting your east-west traffic, and all of that can be done very easily with the routing intent change, right? So you can change it to from the old version to the new version directly from here.
But here, what you displayed just before was the same cluster used for both internet and private traffic, correct?
Correct. Yeah. Yes. Yeah. So under the network virtual appliance, and then now what this setup is, both the internet and private traffic are going to the same cluster.
So we can mix and match, basically, depending on our need, really.
Mm-hmm. Yeah. Yeah. So it's very flexible. Okay. Okay. So next I want to touch base a little bit. Also, what Holly mentioned earlier is when customers have a VNet, right, with multiple subnets, what happens is that with the routing intent, it will actually send all traffic to the checkpoints. Now, the subnet itself, the traffic between the subnets will actually go direct. So let me show you an example here. So I have VNet 8 here, and this VNet has multiple subnets. So the traffic between the two subnets are not inspected by checkpoint with the routing intent. So the routing intent only covers the entire address space of the VNet. So all this traffic will be within this /16 will go direct. Now in order to inspect the traffic between the two subnets, we have to put in the UDR. So here I have two different subnets, and here's what the route table looks like for this subnet. So essentially, I am sending, so this is the .1. So this is the 1088.1, right? So what it's saying in this route table is that anything that is going to 88.2, I want you to send this traffic to the checkpoint for inspection, right? And the same for the other subnets, right? Show you the other subnet route table. So this is the .2 subnet, and they're saying, hey, if you need to go to 88.1/24, go through the checkpoint for inspection. So what that will give our customer is the ability to inspect traffic within the subnet itself, right? So if you put the subnet is /16, you can carve it out to different smaller subnets, and those small subnets will also get inspected by checkpoint. And I did come across one customer that actually do host to host. But that's a little bit, it's you can also do that as well, right? So it depends on the requirement, the security requirement, right? So you have different security levels, and you want to do the inspection within the same subnet, you can also do that as well. So it's you do that with the UDR. Okay, so that's the subnet to subnet. Any questions? Yeah.
So John, real quick, that 123.228 IP that you have, that's the load balancer IP, correct?
Yes, that's right.
The
Yeah.
next hop. And where would we see that? Would we see that in the portal? Is that something, where would we see that IP in the portal? The 123.228.
Yep. So yeah, that's a good segue to the next topic, which is the effective routes, right? So so from operation perspective, you want to see what the routes and where how the traffic is being routed. So you go to see the effective routes, you find that IP. So you can find that IP in two different ways, right? One is obviously logging into our MVAs directly from SSH. So you have SSH, you can get the load balancer IP, and then from the portal, you can get that from the effective routes. I think I have it here. Okay, so not this one. So
I see. So the
once you
whole
have routing
load
intent set,
balancer, sorry. So the whole load balancer is transparent. It is not seen on the portal, right? Like that one, you can only see it through either looking at the route table or looking at consoling into the to the firewall, correct?
Yeah, so it does show up, right? But I want to touch base on the route. So it does show up on the host level. So with the once routing intent is set at the host level. So here I have a virtual machine in a VNet 1, right? It's one of the network interface. So from here, you can actually see the next hop is pointing to the 228, right? That is the checkpoint internal load balancer, right? And then you see the quad 0 route here, and this is actually pointing it to the Azure firewall. So remember the routing intent here. Sorry. Oops. Let me go back to the routing intent there. Under the routing intent, we have the Azure firewall as the internet traffic, and we have the private traffic here. And then what that looks like at the network interface level is that you'll see that the quad 0 is actually going to 132, and that is the Azure firewall. And then 228 is the checkpoint.
Got it.
Okay. So the next topic, I want to touch base a little bit back to the route. So before the routing intent is set, the effective route will look something like this, right? So without the routing intent, you will see all the different networking services that are connected to the vWAN hub, and you will see that the routes are being displayed from these network services. Like, in this example, I have a site-to-site VPN gateway deployed, and these are the routes that I'm learning, right? And you see the various different respective AS number that pertains to these the connections. And then also we have a remote hub. So the hubs that are so this is I'm in West Central, so you also see different hubs and IP addresses that are connected to those hubs as well. So you can see those IP ranges here. And obviously you see all the peer VNet to this hub, all the subnets are peer here. So without routing intent, you expect to see these routes here in the effective routes under the hub. Now, once routing intent is set, right, on the same hub, you will see that all the routes will be consolidated, right? So all the internet routing intent, what it will do is it inject the quad 0 route with the next hop of the checkpoint firewall, and then you have the all the RFC 1918 address space with the next hop of the checkpoint, and then this right here, this range is actually an additional range. So some customers may have internal ranges that are outside of RFC 1918. Those can be added into the routing intent for private traffic, and those IP address will also show up here as well. So that's the routing route table, what a route table looks like in the hub.
Thank you, John.
Okay.
Can you
Mm-hmm.
sorry, yeah. Can you show us where to configure the public ranges to be treated as private, if that's possible?
Yeah. Yep, no problem. So on the routing intent, there's an option to add additional prefix. So as you see that 1, 2, 33, yeah. So just click here, and then you can add the range here.
Okay, perfect. Thank you.
Yep.
So John, one more question. This screen that you had before routing intent, I want to see what there is no quad 0, right, in here?
No.
Okay, so here,
yeah.
so it would use the Azure default internet routing for the traffic that goes outbound.
Or, yeah, exactly. Any solution that would be local to the peered VNet, for example.
Yes. Okay, perfect. And then can I see, so and then the other tab compared to that, the quad 0 now goes through the firewall, right?
Yeah, so the effective routes. It takes a second to load. So route table and default. Yeah, so this will show the effective routes once routing intent is set. So I want to show, yeah, there we go. You see the quad 0 and the RC 1918.
Perfect. Yep.
Okay. I've touched base a little bit already. So going back to at the virtual machine level, right? So, so at the virtual machine level, on the network interface, click on the NIC itself. To see the effective route, you go under help effective route. So at the VM level, NVA level, these are the effective routes and what it looks like. I think we touched base on this a little bit earlier. But you will see that, the two-tier firewall, like, again, the Azure firewall is the 132, and you see that, the 228 is the internal load balancer to the checkpoint firewall.
So this is the NIC of a VM in a spoke VNet of the virtual hub, correct?
Yes, that's right.
Okay.
Yeah.
And to mention that all these routes are added automatically. So as you said before, John, this is all done using Virtual One is doing all of that automatically with nothing to configure.
Yeah. So when customers attach the VNets, they don't even have to deploy a route table. Once they attach to the vWAN hub itself, vWAN will help the customer route that traffic from that VNet to wherever destination needs to go, right? And that VNet's subnet will get advertised across all the connected hubs.
Yeah.
So you can have one region in the US, another region in Australia. So Australia will get that route update automatically.
And question, John, the VPN termination currently in your lab is on the vWAN's virtual network gateway, correct?
Yes, that's right. Yeah. So right now, yeah. Sorry, go ahead. Yeah.
No, so I was just thinking through the flow. So as Cynthia mentioned, this VM is in the spoke, and for it to reach a VPN connected branch, how would that traffic flow?
That will go to. Yeah. So sorry, Cynthia. You go ahead.
No, you go ahead. Sorry.
Okay, all right. So the flow will be from the VNet. It will go through the checkpoint as the next hop, right? So if the IP space is a 10/8, right, RFC 1918 to the branch, so that traffic will hit the checkpoint for inspection, and then from there we'll route it to the VPN gateway, and then encrypt into the branch office. And
Got it.
the
And you
return
also
traffic will follow the
support,
exact same path. Yeah.
sorry, yeah, and you also support that the VPN could be directly terminated on the checkpoint. Is that right? Or that's not supported?
So it is not supported as of this recording.
Okay.
That is something that we're working with Microsoft, and hopefully we'll have it in soon. We'll have that capability very soon. So we're very at the final stages of the testing. So we should have that ready soon.
Awesome.
Where customers can actually terminate the site-to-site VPN directly to the checkpoint NVAs inside the vWAN hub. So there are advantages in having both sides being a checkpoint, and we have a built-in technology that will help customers to maximize the VPN throughput, for example, right? To checkpoint to checkpoint, and also from a configuration perspective, is also pretty streamlined as well. So that capability is coming. So.
Just back to the data path and the question you asked, Neali. So basically here, because we have both private traffic protection and internet protection enabled, the firewalls in the hub become the transit for any flow. So whether it's VNet to VNet or VNet to on-prem.
Got it. Yep. Thank you, Cynthia.
Okay. So next topic, I want to take us to the operation aspects of it, right? So understand that our NVAs are actually installed in a installed in the vWAN hub itself. So some of the functionality that our customers are used to, like such as like serial console access, for example, is not going to be available. Now, with that being said, Microsoft is building in the capability to allow us to better manage these machines. So let me show you an example of some of the capabilities that's building in. So I'm going to go back to the virtual WAN. So one thing that is available to customers now is that customers will have the ability to reboot the checkpoint NVAs inside the vWAN hub. So I'm going to jump into one of these guys here. Under third-party appliance, this is the checkpoint appliance. Under the managed configuration, and then under the instances. So in this case, we have 2 checkpoints. So default is, we can have 2. So we have our IP addresses here, right? So there's an option to restart the NVA. So if for whatever reason the NVA is stuck, right? So we need to reboot, customers can go here and reboot. Another very, sorry, any questions here, Cynthia and Holly? I know that we're in the process of building more capability to manage these NVAs directly from Portal. So right now we have the restart option right now. So.
Okay, clear. Thank you.
Okay, cool.
So John,
yeah.
you're probably going to go into this, but so you do have SSH access to these today, or?
Yes, we do. So yeah, so customers can SSH to these gateways. I want to cover one more topic regarding upgrades before I'll show you guys direct SSH access. So let me jump to that.
Sure.
Quick. Okay, so in terms of upgrade, I've been managing checkpoint firewalls for like 20 years, right? And whenever we upgrade a firewall, there's a lot have to go in place, right? And things will go wrong and can go wrong. And one of the best from operation perspective, one of the best way that I found over the years, right? At least the teams I work with is provision a like for like with the upgraded version next to a version that's already running. So what that allows customers to do is to easily switch right to the new version, right? And then having all the applications team test the connectivity, make sure it all works, all the critical business applications are working, and then also leaving the old firewall, the old set of firewalls in place until a week or maybe a month later, right? Depends on the how comfortable the customers are. So we can follow the same methodology here in vWAN where if the customer wants to upgrade to the latest version, what they can do is that they can install another checkpoint cluster, right? So in this case, I call it this cluster here from and then save the routing intent policy. Now, and then at this point, the customer can go through the UAT, and if the customer detects an issue, obviously within the change window, you can troubleshoot all of that, right? And hopefully, able to resolve some of the issues. And if not, you can quickly roll back by changing the routing intent from the new to the old. And also, you can leave the older gateway in there for like at least as long as you need to. And in case, let's say, a month later or a few weeks later, there is a batch process that's critical to the business that is not working because of the new firewall, you can always go in here and roll back to the old version, right? We store the application. So this is the upgrade process. So this is the major version upgrade. Now, in terms of the minor version upgrade, what we can customers, because we provide customers full access into these MVAs via SSH or from the web GUI. Customers can upgrade a minor version, such as minor patches and jumbo hop fixes. Customer can do that directly on the MVAs. And we have instructions on how to take the MVAs out of the load balancer so that customer can do maintenance on the MVAs. Okay, so that's the upgrade. I want to share that this it's pretty slick. I really like this. The routing intent also allows major version upgrades without having too much headache.
No
and all the routing,
no
right?
cable swapping.
Yeah.
No cable
yes, no
swapping.
cable swapping. Yep. Yeah, those are good old days. So, okay. So any questions here? Before I jump into, I'll show you guys a couple of things on the SSH to one of the MVAs, show you the routes and stuff like that.
Clear for me, thank you.
With the CloudGuard gateways in vWAN, we also allow customers to SSH directly to these NVAs. And in order to get to the NVAs, get the IP information, you'll go to the network virtual appliance. And from here, there is instance information. So you see that all the IP addresses that are assigned to these NVAs. So we have 2 public IP, and also we have the other private IP addresses as well. So you can use any one of these IP addresses to SSH or access the web UI. All right, so now I want to show you guys how to, I'm going to SSH to this gateway here, and I'll show you some of the routes and some of the settings that that'll be helpful.
So John, did you
So,
say you could also SSH to the private IP? Or
correct.
Just the public?
Yes. Yeah.
And how would we
public
route to?
For sure.
Yes.
Good point. So yes, you've got a really good point. So as of today, if you have a VPN gateway terminating at the hub, or if you have an express route terminating at the hub, you can manage those IP addresses, the private IP address. Now, if you have a hub in another region that don't have express route or VPN gateway, then your only option is to manage it by the external IP. That's up to that. Okay, so we're hoping to make that the feature enhancement that will allow customers to manage the private IP. But as a general rule of thumb, if you are managing everything from the public IP, you should be good to go.
And then at the checkpoint level, you whitelist. In the checkpoint policy, you whitelist who can SSH, right? That gets done on that other side.
Yes, that's right. That's right. So from a policy perspective, all of these security gateways are managed from a central security policy, and it's you do that from our smart console. So I kind of have a generic rule where I have a group of my security gateways. My management station can all talk to each other on any service. So this is you lock that down from a security policy.
Got it. So your jump server's IP is whitelisted over here, essentially.
Yes, that's right. Yep. And that's me here.
Mhm.
Okay. All right. So let me jump into the console. Okay, so here I've SSH into one of the NVAs. So again, we can deploy up to 5 NVAs, and default we have 2, right, for high availability. And the first thing I want to show is that once the NVAs are installed out of the box, we will automatically have it peer to the vWAN hub. So one of the integrations that we have as the NVAs are being built, we will actually automatically provision the BGP for our customers. So whenever when ready to have the VPN connectivity or anything that pertains to BGP, you'll see here. So these 2 IP addresses are the hub BGP endpoints, and then you also can see the routes are learned. So these are the routes are being advertised to the checkpoint NVAs from the vWAN BGP endpoints. As you see that, we have our 10/8s and all the spoke VNets IP addresses will show up here, and we'll get that twice. Okay. On the same token, we can also advertise routes into vWAN, right? So I'm working on the remember mentioned earlier that when we do support the site-to-site VPN and eventually our SD-WAN as well, we'll also have the ability to advertise routes to the vWAN as well. So these are some of the routes that we are advertising. So I know that this one I'm doing testing is I'm advertising into the vWAN. And then again, going back to the shell, customer will have full shell access. So any customization that you need to do, you can do so directly from here.
And going back to that output again, John. So this 12.228, is that the what IP is that? So that's this IP on the vWAN side, right?
12.228.
The next hop that you see, 10, 11, 12.
Oh, yes, that's right. That's right. That is our load balancer IP.
Load balancer IP that we saw earlier. Yes. Yeah. And this is how you would get that. Yes.
Yes. Yes. So there are a couple of ways of getting that. So if I do a show configuration, you see that we are in a route map command, we are advertising the 228. So we'll learn that information as we deploy our NVA, either we'll get that information from the API calls, and this is a load balancer IP. So the other way of getting it is look at the configuration. So essentially, what this is that we are advertising the next hop instead of directly to the NVA itself. We're actually advertising our load balancer IP to the vWAN hub.
Yes, got it. Yeah.
Yep. That is pretty much it. Yeah, so that's so with that, our customers have a full can route all the traffic right in vWAN hub to checkpoints, and have full access into the NVAs for customization. Yeah.
Okay. So John, just one question. When the traffic, for example, earlier you had spoke VM and the spoke, when it egresses through the firewall, where do we see that egress IP?
Yeah, you see that egress IP under the instance info. So So this is the public IP address we'll be using to HiNet. So so when the traffic goes out, right, is either coming from the .88 or the .138 address here.
And you can have more
and then
than
on
one?
the check, yeah.
You could have more than one public IPs?
Yes, the feature is not GA yet. So
okay.
So we work with so we did work with PG to have
Okay.
attach additional IP. We tested it works. Just waiting for the solution to go.
Got
Now
it. Yeah,
on
no
the
worries.
on the checkpoint side, this configuration, it's pretty simple. We have under a NAT policy, so we'll HiNet this traffic. So all lab networks, right? The RFC 1918 will go behind this dynamic object, and this dynamic object, so it depends on which gateway it hits. You're always going to NAT it to the external interface. So back to the portal. So it's when the traffic goes either to this NVA or this NVA, it'll NAT behind one of these IP addresses.
Got it. Thank you, John.
Yeah.
I have one more question about the number of SNAT ports supported by a checkpoint deployment in the vHub.
Yeah, that's a great question. So NAT, it can be tricky, right? So obviously we're limited to 65535, right, ports. And we have, over the years, we have developed, so to answer your question, 65535, right? And it also depends on the source destination IP. So I don't have a number, because that can change, depends on the traffic profile. But what I can tell you is, in Checkpoint, over the years, we 30 years, right, in the firewall business, we come across a lot of different use cases, and we're able to address those source port exhaustion issues with the timing of the protocol, and also with the source and destination, and how the packets are being manipulated in the NAT. So I apologize, I don't have a definitive answer for you, but we have a lot of enhancements built in to cater for the port exhaustion issue that we see. Yeah.
Thank you.
Yeah.
Awesome, John. Thank you so much. This was a great session. Really do appreciate your time. Cynthia, any last thoughts before we close?
No, thank you, and thanks, John, for the presentation and for the demo.
Yeah, thank you for having me. Yeah.
Excellent. Thank you, John and Cynthia, for the presentation, and thanks everyone for joining, and I will see you in the next video.